Back. Well, we'll talk about something very important, and people very often ask, how much is pollution? Okay. People also ask, oh, is Delhi more polluted, or Calcutta more polluted, or India is a serious problem at the world level, or it's the United States, or it is a China? Very often we encounter with this problem. Okay. At the broad sense, we always want to know. Okay. So one thing that helps you to answer such broad question is the emission inventory or air pollution loads. Okay. Like I'll give you an example. Okay. These are the little figures from Delhi, for example. Air pollution load is total pollution load in Delhi is 2000 tons per day, for example. Okay, the vehicular emission is contributing something like 1400 tons per day of the total pollution. Power generating units in Delhi is producing about 300 tons per day of the emissions. Other industries about 200 tons per day, and other miscellaneous source, which may include domestic sources as well, the cooking and all, could contribute up to this thing. Okay. Useful information. Why? Just you look at that, you say, oh, we should do something about the vehicular pollution. Okay, because we all need to take decisions. Okay. Well, we need to do something with this one. And then suppose within these things I further have the breakups, okay, in terms of CO, hydrocarbon, NOx, SO2, particulate matter, lead. Then I can prioritize, look, CO is a serious problem in, for example, in Delhi. So I must attack, or rather I must control the sources which is largely responsible for carbon monoxide. I'm just giving an example. Okay. Then we can say, okay, once we are talking about largely the CO is an issue, or we may say particulate matter is an issue, then we should control the diesel vehicles, okay, or the two-wheelers or three-wheelers, and then we can take a decision. To answer these, we need pollutant specific, source specific, area specific information, and a smart database which can quickly retrieve the answers that you may pose a question to the database system. Okay. And see, these questions sometimes can be very general, would be required by the experts, could also be required by very ordinary people to know, oh, well, what is happening in my area, and they may also be required by the politicians and bureaucrats to make a decision. That may also be required at the ministerial level or the interministerial meetings. It can also be required at the international meetings and forum. Oh, well, what is the for example, if I was talking about the greenhouse gases, then at the international forum we always need to pose what are our conditions. In India we are producing so much of CO2, so much of methane. Okay. So that's what is assessment, that is sometimes very, very important, and we'll see some of the uses of this and how to really do this one. What this really is, what is emission inventory? It is systematic collection, compilation and collation of data concerning air pollutants emission in a given industry or an area is referred as the emission inventory. So immediately something is specified, that you are always specific to some area. You can't talk, well, the area can be entire the entire world, but then we need to define some area. Broadly speaking, what it can do, it can give you the broad options for pollution control. Okay, not very specific, broad answer. Assistant air quality surveillance program. Okay, what I mean surveillance means, suppose you are looking for the Kanpur and you did the emission inventory and you find, let's say, in the Panki industrial area or Dadanagar industrial area, you have lots of pollution emissions are high. Okay, then you would like to put your regulatory enforcement, send out the people and the surveillance to that area more often, okay, to see what is happening there. You can also sometimes seasonal and geographical distribution of pollutants change. So your inventory may also have the information. Well, in winter things are like this. For example, some industries are very season specific, like sugar cane industry, for example. Okay, so then you have this thing. Some in, like, for example, the leaf burning is very common, like during the fall time. So then maybe it will be season specific. Even geographically sometimes the pollution changes. So that also sometimes we need to thing. Aiding in regional planning and zoning. Okay, you can say, okay, these are the protected area, these are the clean area. You can do the community education. You can tell to the people that your area is more polluted. What are you doing about this one? You can tell the industry. You can tell the industry. You can prioritize the industry. You can give the listing of the industry. These are more polluting, less polluting. Okay, just because you have some information, and then you can provide a competitive environment to the industry. Look, you are the most polluting, and the industry feels bad about it, and they improve. We all want to improve, like if given the bad publicity, like, so people do change for this one. You can also use the emission information for air quality modeling. What I mean by the modeling is that once you have the emission inventory, you couple this with the wind speed and wind direction, and you can say how the pollutants which are emitting, because inventory is a quantity only, okay, and then you can do the dispersion with the information of the quantity, and you can see what will be the impact. And finally, you can take very good decisions primarily based on the emission inventory as well as the air quality modeling. Okay, and that is how, for example, why the vehicular pollution was controlled in Delhi. CNG, you have gone to the CNG and things like that. It's largely, see, I mean, sometimes you don't need very sophisticated instrumentation. You could very clearly see from the emission inventory the vehicular pollutions are a serious problem. They were contributing out of 2,000 tons, they are contributing about 1,400 tons. So they, like, you don't need models, you don't need experts, you don't need scientists. You can very quickly take the decisions, like, and then they decided to go for CNG, instead of diesel. And things improved, like, and then at more sophisticated levels you can do more fine tuning of the thing. But emission inventory is of great information. Okay, how to make emission inventory? Define the boundaries, as I said. For example, it could be simply GT Road, for example. It could be simply IIT Kanpur institution, and we'll do an example of IIT Kanpur. It could be just the area of the Connaught Place. It could be state, it could be country, it can be continent. Divide the unit process wise, like I'm talking, just giving an example. For the industrial this thing, you also want to divide like certain pollutants if you want to. Then you want to divide the major traffic corridors, okay. Then you need to do the collection of the information, okay. How much, what information, that we'll see later. You also need the information on the raw materials and the fuel quantities. You also need to know the type of process. You might be doing, you're burning a pulverized coal, the emissions will be different. You're burning a coal with the hand fire shovel, the emissions will be different. You're producing, let's say, urea, okay, the technologies are different, so emissions will be different. So you also want to know exactly what kind of process is there, and on top of everything, you also need to know what pollution control devices, because sometimes you will get these things uncontrolled, and suppose the industry has a control device, so you must modify your emissions based on the efficiency of the pollution control devices that are installed. Okay, we'll see how these things are really done. What the people have done, okay, and this has been going on for last 30, 40, 50 years, is people have developed certain factors. Okay, if you are using so much of coal, multiply it by a factor, you will come to know so much of the particulate matter that will be emitted. So some kind of factors have been established, not very easy job to do, but still these are available. Establish emission quantity for a specific process. So for a specific process, there is a specific factor, okay, and a specific pollutant for unit production. For example, if you want to find out the emission rate, okay, an example may be based on the raw material. Okay, if you are using, let's say, for example, I can say if you are using the cement factory, you are using X ton of, let's say, limestone, and then there may be factor for, let's say, for the particulate emission from that thing. So that factor may be quantity of the raw material. The factor will look like something of emission of whatever the pollutant per ton of raw material processed. Okay, so you get the emission, and then you can put the efficiency of the pollution control device that has been used by the industry, because this can vary from industry to industry, and you can find out. Emission rates could also be based on the production. Okay, the factor could be based on so much of megawatt power is generated, so much of the carbon dioxide will be produced, because you are using a kind of particular kind of fuel. Emission rate could be based on the fuel into emission factor. So these things are people have really generated. Okay, I'll just give you an example. Emission factor for power plant is the reference, and we'll come back to this reference again and again. Sometimes the Americans, like most of the time, they do a very fantastic job, and in fact they are the leaders. They are the world tend to follow them. Like it happens. These AP42 were like started in somewhere in 60s and things like that, and they keep on modifying, improving, and everyone, okay, they tend to see onto this one. Of course, people change as per the local condition, but this becomes a mother document for most of the people in the world if you are generating an emission inventory. For example, if I want to find out the particulate matter emissions from the power plant, so the factor is the 6.8 times the ash content in percentage times coal in tons per day, okay, and the unit here will be kg per day. Okay, it's not very difficult to understand how this factor has been arrived at. Okay, but you have to be careful with the units. See, the coal consumption is in tons per day, ash is in percentage, okay, which is A. 40%, 50%, 30%, 6.8 is a factor, okay. 19 into S for example sulfur dioxide, S is the percentage of sulfur, okay. Coal consumption in tons per day, this will be tons per day. See difference unit, tons per day in kg per day. You can, if you really try, you can figure it out as to why this factor 19 has come, okay. And this basically unit conversion and things like that, and you get this kind of information. For example, urea, a urea plant is there, okay, so particulate matter emission could be based on, not on the fuel, but based on the how much urea is produced. So you produce in tons, it should be tons per day, and so much kg per day will be there. And so is the ammonia emissions from urea plant, that could be in terms of the kg per day, and the 5 times the urea produced tons per day will be this thing. So you need, if you have the information, because inventory is always an estimation. It is not something you want to say 29.0612 kg per day. Okay, these are the estimates, reasonable estimates. Okay, emission inventory and objective methods, present practices in developed countries, that we will see, and we will also do a case study. Again, a repetition, systematic estimation and collection of data of emissions of desired pollutants. Okay, you have to always do little scoping of your work. You can't be doing indefinite and infinite things. Okay, otherwise you will never be able to finish. So you should have the inventory that you develop. It should be scope it properly. Okay, I want to do only for SO2 and nothing else. For example, you can decide, and that will be governed by the specific objective you have. Okay, so that's what it's trying to say. For example, how the basic steps are: earmark the area, okay, decide the pollutant of interest, okay, you might decide only CO2 for example, okay, or more, and then you say, okay, locate and identify the sources. Where are these sources? Okay, because the sources must be known to you where they are. Okay, you have to come up with certain methods. Okay, for example, my objective may be simply to find out how much is the diesel and petrol related emission in the city. Okay, then well, my designated area is fixed, pollutant of interest could be related to diesel and petrol. My method could be simple: I go to all the oil depots, for example BPCL, HPCL, Indian Oil Corporation, Reliance people, and say, well, how much is your sales? Okay, and then they'll give me the sale figure, they'll very happily give me, and then I get the quantity that is being used, diesel and petrol, in the city of Kanpur. So the methods, again you have to decide as to what you want, how accurate you want, okay, because somebody will immediately question, well, that is fine, but what about some of the trucks that are coming into the Kanpur city, and they will also consume some of the petrol and diesel, and which may not draw the petrol and diesel from Kanpur city. So there will be questions. So you need to identify the methods, and also to say some extent, how confident you are about the things, and estimate and quantities, and then of course database, as we require for everything, database is required. And then what could be the basis? Okay, you want to compare the cities with similar meteorology, regulatory jurisdiction. Okay, because let's say you want to do for all the district in UP, for example, because UP State Pollution Control Board says, well, we won't want to this one. You may have the economy based. This city is economy is high, let's say Bombay you want to do because economic activity is high or something. So you need to know the basis, whatever that may be. Okay, and then you can decide the pollutant. As you see here, we won't spend the thing here time, but then you can decide which pollutants you want to do. There could be some other specific pollutant which are specific to the city, for example. Okay, and then the hydrocarbons, this, and sometimes this may be of great interest to people working on the global warming and things like that. Okay, then you have to identify what are the sources that you want to deal with. Okay, sometimes you may only want to deal the sources with the anthropogenic sources. Okay, or sometimes you want to deal with only with the natural sources. You want to find out the contribution of the natural sources in your area, because sometimes because you want to quickly know. And it really happens that, well, man-made sources you can control, natural sources the control is extraordinarily difficult. So you want to see this one. Since we are talking about the sources, okay, let's go to the next slide. Natural sources, but they can come from the different, and you can list many more actually. Okay, you can have the wildfires. Okay, this is a natural source. It's considered natural source because naturally the fire occurs, and and you see the problem is so difficult to control the natural source. I don't know how do you control. Of course, they all try for this one. Okay, Malaysia has regular forest fires. Okay, so is US and Australia for that matter. You can also have the volcanic eruption. It causes huge emissions of various gases and particles and dust and things like that. You have the wind erosion, which includes the dust storms. Okay, so you can see here the volcanic eruption, the dust storm, and sometimes all the particles, like the leaves fall and undergo the fermentation and things like that, produce methane and things like that. And sometimes, if you have been attending that lecture, I always remember the Ravi Kant. They say even the plants, okay, they can give the VOC emissions, as he has shown in his lecture. So they continue to emit the things, like some of the plants, like depending on that. So you need to identify the sources. So you have to also identify the industry. Okay, then industry you want to see both process releases, because then you want to keep the mining, because mining causes serious problem. Okay, you also need to look at the combustion, as you see here. You also need to look at the solvents and chemical handling. Okay, and then you also need to see the processes here. Okay, and I have not mentioned here. Okay, and then maybe from the internal combustion engines. Okay, you want to find out these sources. You want to find out the big engines which are stationary, and sometimes, not only sometimes, you need to find out even the automobiles which are not on the road. Okay, I can tell you a good story about this one. Is they were trying to, they're trying to control air quality in certain area, and they had all the sources known to them, and they did very good job, and it was in California, Santa Barbara area, and they said, well, but the air quality was not improving, everything was controlled here, and the models were run, and they said, well, everything looked fine, why is that, still, it was only a little later on that it was found out this, because they are the Americans, the huge houses and huge lawns, and they all were using this thing, and this thing was so inefficient here, okay, and the emissions from this little lawn mower was so much that they came to know that this was a significant problem, not that it was the only problem. Then people started working on the efficiency of this, and you see how this information can help you to do something which you don't even think that can be an issue, and that's how you have to be a little open-minded and be keen observer as to what is happening, because many of the ideas, many of the things comes most by the observation rather than solving huge differential equations. That can come later on, but then this is what was the the thing as you become, like this was had the area and thing. Just an example. So in fact what the Americans do is they make a separate inventory for the vehicles on the road and the vehicles, internal combustion engines off the road, which also includes the tractors and things like that for your agriculture and kheti and everything and things like that. Just to give you the idea and putting importance. Domestic sources, we all know in India this could be very significant source of emission. Okay, I can replace this thing with LPG, but then we also have to consider the various fuels. Okay, some of the refrigeration may require, some may emit CFCs and things like that. Portable generator sets that become an issue in India. Chemicals and solvents which might be being used in the house. Okay, because sometimes we want to find out every source. Okay, you may find that you have varnishes, the wood, and it can cause lots of emissions of VOCs and things like that. So everything needs to be looked into. Okay, then other sources of miscellaneous mass burning or the waste burning that we all see even in IIT. You will see at the end of February, March when they will burn this thing. The wastewater treatment plants are the source of emissions. Agriculture operations, spraying of the pesticide is the source of emission. Biodegradation of the crop residue is the source. What is the main pollutant that comes out? Methane, and don't forget huge amount of ammonia. Okay, people were not even realizing that, and the ammonia levels are largely responsible for the crop residue, for the animal production facilities and things like that. So all needs to be looked into, and all the time emissions are. And then this is not so important, but we want to define the emission inventory also based on the point sources, industrial sources and area sources. Okay, how do we do certain, just we'll go touch some specific methods. Sometimes you can do very specific high level measurements, let's say for example here. And then you really need to do is, this is a little city which you can't see very clearly, you really need to know how many stoves or how many fireplaces people have. And then simply multiply them and you can get the data at the community level. So sometimes you want to do some basic things very well, and then rest of the things become more of the interpolation and things like that. Apart from the factors I have talked about, you can do the material balance, and sometimes you can actually measure it. Okay, you can go to the power plant, you want to say, you can do it based on the coal consumption multiplied by the emission factors, or you can really go with your equipment and put those equipment in the stack, because if you want to have the very accurate information. So like the cost will go up, so will be the quality in this direction, as you can see. Steps involved are planning, data collection, calculation, consolidation, documentation, quality assurance, and that is something which let's keep that. And sometimes for our own sources we have to develop the emission factors. Okay, this exercise is very important, and you see, for example, this is a stove. Okay, you want to see how much will be the emissions, and then you want to develop the factor. So you make all these arrangements for the exhaust, and then your particulate sampling probe, then you have the device where you can collect the particles. And you see here, we don't collect the particles immediately. It's a very interesting thing to note. We don't collect the particles very close to this point. Okay, what happens, because some of the volatile organic vapors that are emitted, that takes a little while. Okay, see, we want that VOCs which are there, which as soon as they come out, they will, within certain region, they are going to condense in the particulate form. Okay, if you take a sample too close to this, okay, you will never capture that as the particle, because we know that these will become eventually in 2 seconds they will become the particles. So whenever you are doing the monitoring at the high temperature, okay, you should have some residence time, okay, so that you are capturing it after 2 seconds. If you want to measure the particulate matter at the auto exhaust, okay, you put the thing probe, put some time, residence time, and then put your filter holder on the back of this. You can't put a filter holder on this one. So the sampling prop becomes very long. Okay. So that is what is something is shown here. So the factors are developed. So it's not one sampling, you do n number of sampling, different kind of stoves, different practices, and then you come up with the factors. And these factors are available here. That is the AP42 that I was talking about. See, I don't know, you probably will end up sometimes doing the job for environmental thing, and then the moment it becomes a issue as to how to quantify them, because assessment is very important. See, sometimes we need to do the assessment even if the things are not in existence. How do you estimate, I'm going to put a power plant, let's say in this region, what will be the emissions? Because you can only base that quantification based on certain factors. So these Americans, and then they very, they kind of disseminate the information so that everyone can use. This is the site. Okay, I'll pass on the slides to you, and this should be somewhere AP42. I can't see, if you can see on the back, it's somewhere AP42. Very classic document. Anyone working a little bit on air pollution, you would know about AP42. It's that important. So, for example, this, and you see how nicely they have listed various sources. You go click, and you'll get all the details of the emissions that might occur from the various sources, including residue emissions from the walls, the flanges, and at different pressures and things like that, and miscellaneous data, greenhouse gases, metallurgical industry, anything, like the list really goes on, and evaporative losses, solid waste disposal. Okay, who would think that it will cause serious air pollution, but then it's all listed there, and we all very frequently use all that information that is there. Okay. So, for example, I made this slide for you that I clicked onto this one, okay, and then I get more detail about the external combustion sources. Okay, and then again, you need to define what kind of coal that you are using. Is it anthracite coal, or you are using the bituminous coal or subbituminous coal? Because all the emission quantities will be very different. Of course, doing the things are simple, but you should still be exposed as to how this is done and where the information is available. Okay. Right. Okay. Finally, if you further go inside AP42, it may look like this. Okay. Let's see. I have not seen this, but let's see what it says. PC stands for pulverized coal, dry bottom. See, now the boilers may have different bottoms. Okay. Sometimes boiler has the wet bottoms. Okay. Why they have the wet bottoms? Is it is something the boiler, and then you are supplying the air from here, and they have the boiler, and they'll put some water on underneath this. So this water provides a seal really, so that nothing like more air is coming from here or something like this, because here you are firing the fuel and here you are firing the air and things like that, but you don't want the things to come from here. Okay, so this, once you have provided some layer of water, okay, water is always very good as a seal for the gases and for the air. Okay. So it all emissions, like to give a little feel, the emissions will be different depending on what kind of firing, what kind of combustion you have. So it may be different for pollution, pulverized coal, dry bottom, wall fired, it could be wall, or it could be tangentially fired, for example. So, and for the bituminous, okay, so there is some code there. For sulfur dioxide, 38S in the pounds per ton. In the kg per ton, it will be 19S, if you recall, I said that one. So emission factors for NO2 is 22, for it will become 10 for in terms of the kg per ton, and then they are giving the rating. Yes, what is the confidence level the US EPA has on these emission factors? So you can also at the end you can say how reliable you are about the emission quantities. Okay, so here you see A, C, and things like that. And similarly for carbon monoxide, okay, good information. I think A was very good. So depending on what kind of combustion you have, and let me tell you again and again, you go to AP42 and you can almost most of the time you can see your process and you will have some information on that, or if you don't have, then you generate your own information. So this thing is very, very important. And then in addition to the emission factor, they also describe the process, okay, which is very good. You get an idea about the process of the things and things like that. So this was just an example, because we don't want to go and many more things are like this. Now what I'll do is I'll show you an example how this is really done. Okay, and this example, and recently what we are trying to do here at IIT is the emission inventory for the Kanpur city, which Kanpur looks something like this. This emission inventory, whatever I talked about, we are trying to create and make this one GIS based. Okay, so that person has a map and he can click in this area and then he can find out. He can write a question and then we'll get the answer and things like that. So we are working on that. Your student Neha Prasad, she's working on this, and also the information is being sent. Lots of information, the raw information is being collected by. You will be surprised that to cover the entire area, we have involved some 20 people to do the emission inventory. And for the vehicles and emission inventory, what we are doing is we are fixing the video cameras in Kanpur city, and then because you see it's so difficult to send out the people, and people start from morning 8 o'clock until night 10 o'clock and counting the number of vehicles. So what we are doing is we are setting the video cameras all over the place and then make the film, bring those films in the office, and then the boys can sit down in the night or in the evening and then they can count the number of vehicles that are going by, because we need that information to get the vehicular pollution. So quickly we will, I'm going a little fast because I don't want to encroach onto the time for the next class. So this is for for IIT campus that was done. Okay, so you'll have the little field. Unfortunately, this thing doesn't look very good because of the too many lights. This was done for the campus. Okay. Objective was identification and quantification of various sources of air pollutant in the IIT campus, mobile and stationary. Quite please. Physitive, which is important. Focus on the road dust emissions. Interpretation of emission loads. Type of pollutant, type of sources, campus emission profile. And then we should interpret the data. We wanted to compare how the data from IIT Kanpur will compare with the Kanpur city, so that it can make you feel that well, it may be possible that 15,000 people here are causing a greater problem than the many 100,000 in Kanpur, because it may happen. So there is always that comparison is a good idea. Okay. Methodology, again quickly we'll go to the same thing. Designate the air shed for the boundary of IIT campus. Okay. Commercial related sources, stationary sources. Domestic fuels, cooking in the hostels. You see, you need to cover everything then. Okay. You have to be serious about the thing. Activities at the commercial areas. You have the DG sets, mobile source on the road, mass burning, leaves and garbage, etc. And non-combustion related sources also that you have to consider. That will include road dust, construction activities on the campus, and evaporative losses from the, even went on to see the evaporative losses at the petrol pump that we have. Okay. So you do this serious job. You try to identify, and such kind of tables are made. Identification and classification of the sources. Automobile emissions will be fuel firing, it will be point source or the mobile source. Then you can go for the cooking. It will come from the residential area. It will come from the, what do you want to see here? It will be a mobile, it will be a point source. Restaurants, cover every restaurants here. Hostels, diesel generators, we also include aircrafts. Why leave the aircrafts out there? Okay, because we have aircrafts and that are used. And then you see, you have to become very local. Okay, yesterday there was so much of fumigation, if you recall. So we need to consider everything. Okay, so the fumigation, okay, this is non-fuel sources, okay, road dust, and then this road dust we consider you can also say the point source or the area source or the mobile source. So that classification you do. So this is what you need to do. Then you look at the other information, the geographical information. So much acres, total residential houses so much, total population of students, it was like the earlier data. So this is a little old. Population of staff, this one, and total population approximately on the campus was 15,000. Probably it is a little less, I guess, but we assume this to be, we took as a 15,000. Okay. Then estimation of the emission that we want to do are from the cooking fuels. So we went to the residential areas, okay, type 1, type 2, type 3, 4, 5, include servant quarters, and don't forget SBRs, okay, because that we are taking little residential hostels, etc., including VH, okay, because they also emit this, and all the canteens in the hostels, okay, and the commercial activity, restaurants, empty shops in that area. In fact, you will be surprised that when we are looking for this one, we went and find out the SIS security people also has a mess of their own. So that also is considered. So okay, so this is information that was collected in terms of the LPGs per day. Residential area, this was so much. The wood was largely from the hostels as well as, okay, the mess was here, and these are the servant quarters people were using the coal. The students went there and then they weighed the things as to how much wood they were firing and things like that. Coal is not used in the residential area, and then again from the messes and the canteens, like now things have changed. Okay, this was done, I don't know, 3-4 years ago. Mess was also using wood, and then also using coal, and the restaurants and empty shops were using coal, I don't know for what. So then based on this information, not only you do the pollution estimation, you can also use how the energy is being used. Okay, if you can manage your energy, you can manage the energy. Residential area, okay, where most of the energy was coming from LPG, and from the messes and canteen, it was again LPG, wood and coal. Restaurants was largely LPG, and in empty shops, the shops there you see here, the shops near empty shops, they use a lot of coal, so you can see the coal. The energy supply by fuel type, this information, LPG was large major source of this one, energy in the campus, so was the wood, and the coal was not small either. Okay, then you compare per capita domestic energy consumption. IIT Kanpur was little higher. Okay. We use more energy than the Kanpur and India. You see here, this data is for the entire country. See, poor people, including the rural areas and things like that. So in urban areas we may sound very good, but clearly we are not using more energy, we are also creating more problems. Okay, so this gives you lots of understanding as to what is happening and things like that. Okay, emission factors were again taken from the from AP42. So what you see here is, if you are so much of various pollutants you see here will be emitted in terms of the grams per kg of LPG burnt. It will be 5 grams of particulate matter per kg of the burnt. When for example you come for the CO, okay, for wood the CO would be very high. These are all the factors taken from the literature. Okay, it's nothing that that we have done. So here, for example, if you look at the coal, particulate matter emission is high. Okay, so is the SO2 because sulfur is there, whereas LPG produces with some fine particles. LPG is only related with NOx. So there is a difference here. So LPG will produce some NOx, not the particles and things like that. So you collect all this information, and then the other information has been collected from your quantities and things like that, and then you can find out the emissions. For example, the NOx emissions. So you say mostly the residential areas were largely responsible for the emission of NOx, and so was the all messes and the canteen, and the restaurants were small. So neck and neck. Okay, but then you can see here is mostly it was from the LPG and wood. Wood came from the servant quarters, and here the most of the NOx emissions from the hostels were coming from your LPG and the coal that was being burned that time. So you can get this information and take some decisions. Okay, SO2 emissions was like again largely from the coal. Okay, so no other source of SO2 emissions. So the particulate matter emission, again coal caused a lot of problems, so particles were mostly combustion oriented, were mostly from the hostels. Same the CO emissions, residential area you see here, this is from the wood that is being burnt. Coal and LPG was insignificant, there will be no CO from LPG, and the empty shops, and total emission then from the domestic fuel. So this picture will look like this. Okay, then you can say who is responsible for what. The CO is how much, the particulate matter is how much, and so on and so forth. Okay, per capita emission rates in domestic fuel. So SO2 high, okay, because we need lots of energy, like NOx was high, particulate matter was high and CO was high as compared to the Kanpur. Okay. So you can see here that we cause more pollution in terms of the per person. More richer you get, more pollution you cause, like energy consumption versus rate. What are we trying to compare here? The energy was used mostly in the residential area and this. So most of the source was LPG, and the source was again LPG and the coal. Okay. This is interesting. So you want to do for the automobiles also. You see the map of IIT Kanpur roads, and then you divide the road in A, B, C, D, E, F, and the students went and they did the traffic counts. Okay, and all the locations, we're all defining various different roads that they are there. And emission factors, then you see here what you need is the kilometer run. Okay, so the kilometer run. So you can, once you have the traffic count, you can find out the kilometer run. Apply the emission factors, and you see here the diesel vehicles, the trucks that they were coming, okay, because of the construction activities, they were the largely responsible, and especially the particulate matter was coming from the this thing. So this is air pollution load due to automobiles, that you can see from which road there was a larger problem. And there were different roads, as you can see here. What were the issues at different roads? Why I am giving you all this information is that you can get a feel. So then finally you combine all the information and say NOx contamination by the different type of vehicles. So buses and trucks 47%, and the tractors also was not so small either. Okay. So if you want to take a decision for the campus or something, it was just an example, but then you have this information for the entire city if you want. Then you can take the decisions. I want to be quick because this is a particular matter. You see contribution of different type of vehicles. Okay, CO emissions from different vehicles you can see here. Contribution of the composition of the various pollutants by different vehicles. That is the total. Okay, now CO, NOx, particulate matter put together. So the 54% of your emission is coming from the bus and trucks. Okay, two-wheeler, four-wheeler was not so much. Now number of vehicles have gone up in the on the campus. This is the composition of the total pollution load due to vehicles. Okay, this is same slide. Then the student also did how much the road emissions that will happen. I'll send you these slides. You can understand these. Okay. See here, we also need to know that how much is fugitive emission from the road. So what the students did, they take certain area, okay, take how much square meters is there, and then they vacuum clean this one, okay, and then they want to find out how much is the loading of the particles which is there on the road. Okay, total road covered the 5 number of samples taken each site locations were 2, and then 2 samples have been collected from each place, and these samples have been analyzed for silt content, moisture content, and on the basis of the concepts given by US EPA, the emission factor for each road has been calculated, and I'll show you how it is. This is the equation to estimate the emission. Okay, so emission you estimate in terms of grams per vehicle kilometer travel, and we are doing for the particulate matter. Don't forget that. K is the particle multiplier, silt load that you need to find out per meter square. You took the sample from the ground, and then you see how much of the silt content, and then you see what is the mean fleet weight of the vehicles. Okay, you have X number of trucks, Y number of cars, Z number of two-wheelers. You can find out the weighted average weight of the vehicles in tons, and then you can find out how much vehicle kilometer travel will be there. So you can again find out what will be the emissions. Okay, this is the K factor. So not only you can find out PM10, PM2.5, all you understand PM10, 2.5, PM15, PM13, and then you see the K value is becoming smaller because PM2.5 will be smaller than PM10, okay, in terms of the emissions. So you see this is also changing. Okay, how the students did was, this was the procedure that they followed: dust collection across the road, estimation of the silt content, fine, estimation of silt load in grams per meter square, hourly vehicular population they had, so they knew hourly how much vehicle kilometer travel was there, and the mean vehicle kilometer travel they could find out hourly, because they knew hourly 4 trucks were passing and 16 cars were passing and 200 scooters were passing, so they could find out the hourly vehicular population. So based on that they find out the mean weight, and then finally they apply the factors, and then this is just a picture. The students were taking the sample at the IIT gate. So you have the bag on the back here. So you suck whatever is there on the ground, and the air will pass through the bag, and the particles will be all trapped inside. Bring the bag, take a newspaper, put everything there, and weigh the newspaper. Okay, and then you know how many grams of the area you had sampled. So grams per meter square is the total dust that was there. Find out the silt, take a little sample out from there, do the little sieving, you know, like what is the silt is what size? 75 micron. The sieve will be, I think, 200 mesh. Size of the silt. This one they really did physically, and they could estimate the things. Okay, then they came with the emission factor, then total pollution load for the various road. They had the length, they had the mean fleet weight, they had the silt load. See, that varied. Okay, but our roads are similar to each other, so the variation was not so much. So emission factor for PM10 in terms of the grams per vehicle kilometer travel, and then finally this information, depending on how much kilometer travel or the distance, they could find out as to this, and they could indicate that was road AD, that is the main road, okay, that has the highest dust emissions. Okay, this example, this you need to do for the entire city, and before you can take any decision. After all, we are here to study, not only to pass or something. You have to do the work on the field. You have to take the decision. You have to make the difference. Okay, and unless your knowledge, unless your approach, unless your observation is good, what decisions you will take? And that's what is a little training that you go through in the process. Okay, the various loads that you can get from the. Okay, this also was done for the fumigation. Okay, this was a very interesting thing. We figured out, the students went and figured out what they are using for the fumigation. It was a melathon that you use for the killing the mosquitoes and things like that. Is used as an insecticide of this one. What they were doing, the mixture of high speed diesel, which is 95%, and 5% melathon, okay, by weight. They will mix, and that at about 400 degrees Celsius to produce the smoke, okay, they were producing, and then to kill the insects and mosquitoes. The emission from the melathon fumigation could be due to the combustion of diesel in the hot chamber and direct vaporization of the melathon. So unfortunately there was no factor that was available, but you apply a little science that you know that kind of temperatures were there, so that you can see what is the possibility of vaporization of the melathon and the diesel smoke and things like that. There was some estimate was made. It was just estimate. Okay, sometimes you can even call it more like a guesstimate, if you like. It was more like a guess than the estimate. So it was more like a guesstimation that we did, and this quantity was estimated. It was nearly found that, well, some of the sulfur could also burn. This could be the CO2, and melathon is coming out as a vapor, which eventually condensed. So we took the entire melathon as that will condense as a particles. So we could quantify as to how much will be the particulate contribution of the melathon. Okay, and yeah, it is injurious to us. I mean, more injurious to the mosquitoes. But then, of course, melathon is an insecticide, so it will affect you also. I mean, there's no doubt about that. Okay, so you can see from the melathon and diesel, and these were more taken as the SO2 emissions, and particulate were also done. Emission from the diesel generator sets. We went to the DG set people. They have the 3-4 DG sets, and then they gave the number about 10 hours per month is that frequency they were using the DG sets in IIT Kanpur during that time. I don't know if it's more or less now, but then you can find out depending on the factors were there in the gram of emission per kilowatt hour. Okay, so that factors were available, and you could estimate practically everything from there. And then pollution load from the various DG sets. Okay, and the pollution load scenario. Overall, the picture looked like this. Total emission for the city or for the campus was found out to be like this. Okay. You see here, automobiles were high, 45% contribution, domestic sources were not small, and to our surprise, okay, the DG sets contributed some like 3%. Okay. We again checked, and the fumigation, so I'm sorry, the fumigation was 3%, and the DG sets, or am I reading wrong? Fumigation and fugitive dust, okay. The DG sets was this amount, okay, and there was fumigation was insignificant in terms of the total this thing. And then you could exactly say, okay, the major problem comes from the vehicles and from the domestic cooking, as you can see here. Combustion air pollution in terms of the campus, 50% was carbon monoxide, SO2 and the particulates and things like that. And you could also say the emission rates in grams per day, and from the automobiles how much it was there, from cooking, from DG sets, from fugitive dust and fumigation, so that quantity. And then there were some conclusions that we can escape for a while. And I'm not shown this one very quickly before I end. One of the mess was already privatized, and we compare the emission and energy uses of a private mess vis-a-vis the Sarkari mess. And then we did get the emissions were low, energy efficiency were high, and then we could not explain as to why so much of energy was required in Sarkari mess compared to the private mess. And it's all up to you to figure it out as to why it happens. The private people were very efficient. And then we also, not that our recommendation was followed, we also said that if you will move on to the LPG, your energy efficiency of cooking will go up, and so will emission will come down. So it made all the sense, okay, to go for LPG and do away with coal and wood in the mess. I don't think they have kind of to cover this thing, but eventually LPG has to replace everything, and that will improve both your cost will go down eventually, and so will be the emission. We'll stop here.